In the previous lesson, lesson 2, we talked about how to find the gradient of a straight line given 2 points. In this one, I want us to talk about how to find the intercept and gradient of a line given either equation or points. If you have not understood how to find the gradient of a straight line given 2 points, you can go back and review lesson 2 before you come to this new one. But in this new one, let's start by writing the equation of a straight line. The equation of a straight line is given like this. Y is equals to mx plus b. Can you note that this b can be replaced by another value? It's not a must you use b. You can use c, you can use d, you can use a, you can use any value you want. It's not a must that you use b. But in our case, let us just use b. So, in this equation, m represents the gradient of this line, which is given by the change in y whole over change in x. If you don't know what is change in y whole over change in x, you can go and review lesson 2 and lesson 1. You have taught this concept there. Then, b represents the intercept of this line. This one represents the intercept. I'll show you in a minute what intercept means. Then y represents just the normal y coordinate. And then they can maybe be something like 0, 0 or another value. And then x, this one represents the x coordinates. They can be anything. So, these two have no problem, y and x. The most interesting values, which of course in our case we are interested in, are this m and this b. So, let me show you. Let's start with b. We'll show you here. So, b represents the y-intercept. But what is y-intercept? Y-intercept is the value we get from a line where it cuts the y-axis when x is 0. So for example, let's look at this line. You see, in this line, here, both x and y are 0. But as we go like this, horizontally, x increases, x becomes 1, 2, 3, all the way to maybe 13. But y remains to be 0, meaning there is no vertical displacement. We only covered on horizontal distance or horizontal change. So, in that case, we say these values are for x when y is 0. Then the same case, if we go upwards like this, you see, here y, the y-axis, the values keep changing, but there is no horizontal displacement. So in this case, we say the values of y increase while x remains to be 0. And therefore, when I talk about y-intercept, I mean where, for example, a line like this cuts the y-axis. For example, this one cuts it at 2 when x is 0. So you see, if I was asked the y-intercept of this line, I would say b, which represents the intercept, is 2. Why? Because this line cuts the y-axis at 2 when x is 0. How about this one? This one the y-intercept is -2, meaning b is -2, meaning the line cuts the y-axis at -2 when x is 0. So the y-intercept becomes -2. So with that knowledge, can we try to enter some values here for gradient and for intercept, and we see how this line moves. For example, let's say the line has an intercept of 4 and the gradient remains to be 2. So if I plot the line, you see it comes at 4, meaning the y-intercept of this line is 4, representing the value of y, where the line cuts the y-axis when x is 0. And if you check on the equation of this line, you'll realize 4 is put here, meaning this is the intercept of the line from our equation, where we said y is equals to mx plus b, and b represents the intercept of the line. Can we try another one? Let me put 6. So you see, still the same case, and 6 comes here, meaning it is the intercept of the line. So that is intercept. For the gradient is changing y all over changing x, and that one we talked about it in lesson 2 and lesson 1. But if you want to identify it from an equation, it is represented by m, just the value before x. Here in this graph, for example, in this equation, the gradient is 2. So with that knowledge, can we try to solve some problems about the slope and intercept of a line? So for example, if somebody tells you to write the equation of a line with the slope m equals to 2 and the y-intercept is -3. First, we already know that the equation of a straight line is given by y is equals to mx plus b, where b is the intercept and m is the gradient. But in this case, we are given m, which is 2, and we are also given b, which is the intercept, as -3. So we only need to pick these ones and replace them in the equation. In this case, it will be y is equals to 2, to take the place of n, 2x plus b, which is -3. I put it in brackets because it's negative, so that I can open brackets. And when I open brackets, it becomes y is equals to 2x. Positive multiplied by negative is negative, so it becomes 2x minus 3. And that is the equation of the line. And if you see well, this equation follows this format where 2 is the gradient and -3 is the y-intercept. Can we try another example where we are told find the slope and intercept for the line y is equals to -1/2x plus 4. So in this case, here now, our equation of a straight line is given by y is equals to mx plus b, where m is the gradient of the line. So in our case, m is given by -half, and b, which is the intercept, is given by 4. Can we try to enter these values on our interactive graph, and we see if it will plot this as the equation of the line? So we have here the slope is -half, which can be written as -0.5, and the intercept is 4. So if we plot that line, we realize that it gives us this equation, which is y is equals to -0.5x plus 4, where 0.5, negative 0.5 is the gradient, and 4 is the y-intercept. Let us try to do the last example that we are given and determine the intercept of the line passing through points A and point B. And we are given the points. So the points are A, 0, 2, and B is 4, 10. So we already know our equation of a straight line should be y is equals to mx plus b, where m is the gradient and b is the y-intercept. So here we can start by finding the gradient. If you don't know how to find the gradient, you can review lesson 1 or lesson 2. You'll get the concept. But in this case, gradient, which is m, is given by changing y over changing x, which is given by y2 minus y1 divided by x2 minus x1. And in our case of these values, this is x1, this is y1, this is x2, this is y2. So our gradient is given by m is equals to y2 is 10 and y1 is 2, then x2 is 4 and x1 is 0. So it becomes 10 minus 2, which is 8, divided by 4 minus 7, which is 4. So the gradient becomes 2. And now that we have the gradient, what we do next, we just pick either these coordinates or this any set, any pair can do. So in our case, let's start with this 0, 2. So if I start with this 0, 2 and saying, we already know this is our equation of a straight line. So I can say y minus, what is the value of y here? y1 is 2. So I say y minus y1 is equals to m into x minus x1, like that. That's how we find the y-intercept. So I just say y minus y1, our y1 is 2, then is equals to m, we already know m is 2, into x minus x1, but we already know x1 is 0. So it becomes y minus 2 is equals to 2x, if I open brackets here, minus 2 by 0, which is 0. Hence becomes y is equals to 2x, and then I pick these two, I take it the other side, it becomes positive, then 0 plus 2 becomes 2. So it becomes y is equals to 2x plus 2, where 2 is the gradient, and this other 2 is the y-intercept. And that we also know the gradient, we can try the same with the coordinates of b and see if we get the same line. So if I say y is equals to mx plus c, and I already know the gradient is 2, so we did that, we know the gradient is 2, then I say to get c or b or another value you put here to represent the y-intercept, I can say y minus y2 in this case, because we are dealing with the values of b, is equals to m into x minus x2, because we are dealing with the values of b. So I say y minus y2, what is y2? y2 is 10, is equals to m, we already got the gradient, which is 2, into x minus x2, x2 is 4. So it becomes y is equals to 2x minus 8, I just open the brackets here, but then this then I take it the other side I had, because here it was negative, so it becomes y is equals to 2x, negative 8 plus 10 is positive 2. So, it doesn't matter whether you use the coordinates of A or B, both will give you the same results. Since we were asked about the gradient and the y-intercept, then it means m, which is the gradient, is 2, and also the y-intercept is also 2. Can we try to enter these values in our interactive graph and see if it will plot, it will give us the equation as y is equals to 2x plus 2. So the slope is 2 and the intercept is also 2. Let's plot the line. Yes, you see, it gives us the line as y is equals to 2x plus 2, the same we got here.